everyone. March the 8th. All right, let's do this. Alternating groups. There is a circle of red and blue tiles. You are given an array of integers colors. An integer k. The color of tile I is represented by colors I. Colors I equal to 0 if it doesn't matter blue or red, it's just like two colors, right? 0 and 1. An alternating group is every k continuous tiles in the circle with alternating colors. Each tile in the group, except the first and the last one, has a different color from its left and the right tiles. Try the number of alternating groups. The first and last tile considered to be next to each other. Oh, hold a second. An alternating group is every k continuous in a cycle with alternating colors. Okay, so we have here we have some issue with this. There we go. I have some issues earlier. Okay, so we have 0, 1, 0, 1, 0. 0, 1, 0, 1, 0, 1, 0, 1, 0. Yes. So every k is equal to 3. So we say every 3. So these 3, they form 1, right? These 3 form 1. These 3, so I have 3. But these 3 do not. These 3 do not. And these 3, we come back. Oh, yeah. K goes 6, so we'll go 6. 1, 2, 3, 4, 5, 6. Yes. And so I think it's sliding window again, right? I think it's sliding window. You start from position 0, go k. K is smaller equal to length, right? So you go sliding window, you start from 0, you find k, right? But how do you know if they are alternating? What is a quick way to check if it's alternating? So we can go from 0 and then we just check, go. We just find alternating, okay? So we start from position 0, right? And we will go. So we find first a stretch with alternating. What would be the situation with not alternating? I would just find stretches, right, without alternating. Maybe we can start from there. We find stretches that are not alternating. Right, it's like an island, right? We find an island, another island, another island. And islands are not alternating, and the ones we can consider are only from the edge of the island going out. So in this case, I want to use the original as an example. All right, 0, 1, 0, 1, 0. And in fact, because it says 3, I can attach 2 more to the end. Right, so we don't have to wrap around. Because you don't have to attach another one. If you attach another one, then you kind of already repeating, right? Because if you attach another one, you're repeating. So basically, you'll attach k minus 1 to the end. I think I'll do that so we can avoid a lot of the issues, right? And then we will scan through the whole thing and find islands. So in this case, we have this is the island, right? This is the island. Now, once we find the island, we basically break it, right? We find all the islands, and we have from this position to this position, everything inside is alternating. From this position to this position, let's put do, right? Everything inside is alternating. So now the question is, how many do we have? So this is 0, 1, 2, 3. 0, 1, 2, 3, 4. So from 0 to 4, I have 5, right? I have 5. And then we have 3, 3, 3. So how many do we have? For a size of, so give me a size, and 5 is a size minus 3. Or you can say 4, this is 4 minus 3 plus 1. So 1, 2, 3 plus 1 is the index of the last one. So this minus 0 plus 1 is the answer. So basically, we can say the index, right? The index, so we can say the high minus k plus 1 minus low plus 1. So equal to high minus low minus k plus 2. That's the total number. So in this case, 4 minus 0 minus 3 is 1 plus 2 is 3. So we have 3. And in this case, I think it will be negative, right? 5 and 6. So we are doing 6 minus 5 minus 3 plus 2. This is 1. This is equal to 0, right? This is equal to 0. And in fact, that it becomes 0, it's rather coincidental, right? Because if I can get this value really high, this can be like 1,000. It doesn't matter, right? It doesn't matter. The formula is still the same. The formula is still the same, and this one will become small or equal to 0. And then if this have one more, right, then this will be like a 2. 2 minus 1, that will be negative 1. That will be 1. Yeah. So yes, so we do that, and then we are good. Now, is this going to be very efficient? I am not so sure, but it could very well be. Oh my god, it's still running. Oh dear me. So the query succeeds, but Lord, it takes a long time. We're looking at 5 million. 5 million, because the failure accounting towards more than 100k failures. Yeah, I think we need to put some restrictions. Now, this is not related to what I'm doing right now. It's basically work. I think we're querying too much data. We have to cap it. But anyway, I think we have a solution. Let's try it. Let's give this a shot. And the idea is we will... Okay, so another ideal is, can we not attach? Can we just wrap around? The wrap around has the issue of, I mean, it's 10 to the 5th. and the maximum is 10 to the 5th. So I don't know, maybe it's good, or maybe we need to wrap around. But wrap around requires some more thought, especially going towards the end, right? Let's not do that. It's just for so wrap around. So I basically go from the start, right? I smaller than, so in this case I go 0, 1. So I go length is 2, right? So smaller than k minus 1, I plus plus. And I can just call it colors dot push back colors I. Right? We just add more things towards the end. And once that, when you say find consecutive islands, right? Find consecutive islands. And I have a res should be 0. So we're gonna start from the beginning, right? And every time, so we have a low, okay? So we'll have a high, we'll move, and if it's the same, then we just keep going, go, until it's not the same, right? Until it's not the same. Okay, low and high. All right, low and high. So this is like a low, this is a high. So when you find the low, you need the previous high, right? You need the previous high. So you go pre-low, pre-high. Well, and just pre-high is important, right? So it's pre-high, and then current ago because I'm trying to do this without. Okay, so the first time you find they're equal. Okay, then you set low and a high, and then go next one. They're still equal. Then you update high, update high, update high, until they're not equal again. Then you have a low and high. Then you have a previous, right? You have a previous high, and then you can use the low and the previous high to do the computation, and then you swap. Okay, so we do need, so I do need a pre-high, well, set it to 0, and low we will set it to 0, but low it doesn't really matter. Okay, it doesn't really matter. So it's the first time, actually we should set low equals -1, okay, and then we say for int I equal to 1, smaller than k, no, smaller than colors dot size I plus plus, right? Each time we say if colors I, right, is equal to colors I minus 1, okay? And then we say if low is smaller than 0, that's the first time, then we will set low, right? We'll set low equal to I minus 1. That's the beginning, right, of the island. And if low is already large or equal to 0, then means we have one, then we don't care. We just keep moving. And we'll have an else, right? Else is when the two are not the same, right? So the current and the previous is not the same. Well, when it's not the same, then when it's not the same, I have the low. I basically need to check the low, right? So if low is larger or equal to 0, then I can do some pre-low stuff. If low is smaller than 0, which means, which is not possible, right? Because if they're not the same, well, it is possible. If they're not the same, right? If they're not the same, If they're not the same, you just keep going. Keep going, keep going, keep going, keep going, keep going. All right? Yeah, depends. If low is logical to 0, so that means a stretch is end, right? A stretch has ended. So in that case, this low will be used with the previous high. So we can say rest or plus equal to low minus, the formula is low minus previous high minus k plus 2, right? Minus k plus 2. And actually, we shouldn't do that. We should say int v equal to this. I have a bad idea. Res plus equal to std maximum of this and 0. Right, so if it's smaller than 0, I just ignore it. That's if low is larger equal to 0, and I basically handle the previous one, right? And once I handle the previous one, I need to reset. Because now I have a new mismatch, right? Now I have a mismatch. So I'll reset low equal to -1, because we don't have a low. But we reset it, and previous high need to reset to I minus 1. Okay, so I need to do that. Else, I don't think we need to do anything else. This is pretty much it, right? And at the end, when we get out, we also have a previous high, because I can have a previous high and I can just keep going towards the end. And I think we'll do exactly the same thing, if I'm not mistaken. I think we're having too many. Okay, so essentially now we can say rest or plus equal to, I can return rest plus 2 std max low, right? Because we get out, it's actually not low. We don't have a low anymore, right? We don't have a low anymore because let me think. So when we get to the end, right? When we get to the end, right? We might have a low. Right, so we say if low is smaller than 0, then low shall equal to colors dot size minus 1. Right, that will be the low. And well, do this low minus pre-high minus k plus 2 and 0. All right, let's give this a shot. We went through this pretty fast. Didn't give it too much thought, and hopefully it is not too bad. Okay, looks alright. And put some thoughts into it. This one is 3208. So to make the wraparound easier to work with, we can append k minus 1 elements from the beginning of the colors array to the end of the array. Then we look for stretches, right, of repeating colors. Right, stretches of repeating colors. Once a stretch is found, we can label its beginning and end, right? Beginning and end as low and high. Then the stretch previous high and low, right? Previous high and low inclusive must be alternating. We can find the number of alternating groups with length k using previous high and low. And we keep doing this until the entire augmented colors array has been traversed. Okay, let's see if we get lucky. I mean, it's getting kind of late. So we do have to, if this one doesn't work, we'll have to do something else and come back to it. But luck will have it, we got it done in one shot, and performance is decent, 73, 50%, which means it's just normal, right? It's just normal. It's a very normal distribution. So the question is, do we have a better solution? I think there is going to be a better solution. This is what we do, expanding array and a sliding window, on plus k. Yeah, I think that's exactly what we're doing. Might be slightly different. Let's see what they do. Okay, this is exactly what we do. And initialize the bounds, left and right. Check if the current color is the same as the last one. So basically, it's just check the current, pattern breaks, reset window from the current position. So if it's the same, left equal to right, right plus plus. Okay. If it's not, then we expand. So skip. And then we add every single one. Yep, that's same, but I feel like I'm always more comfortable computing, right? Computing the total number by finding the beginning and the end, and then use some computation instead of just keep adding. I think that's a very big difference between my way of thinking and this. But I mean, it's not exactly the same, but overall, I'll say it's pretty much the same idea. But this is sliding window where you can just keep track, right? Keep checking. So here I am tracking the repeated region, right? And this is directly tracking the alternating. So it's the same idea. To pass, how many consecutive elements follow? And to ensure that we don't miss any sequence, we break our solution into two separate passes. The first pass scans the array normally and counts valid. Then, to account for the sequence that might wrap around, we perform a second pass over just the k-1 element. The key detail here is that during the second pass, we don't reset the count. We continue from where we left off in the first pass. Okay, so it's the same idea. Yeah, this is the same. Tracks the length of the current alternating sequence. We have a last color. If the current is equal to, we reset the length to 1. Otherwise, we get a count of the size of the alternating, right? larger equal to, then we increment. And then last color, I get the last color. So once this is the first forward pass, and then we're gonna wrap around, we do this, but we have the same number on the alternating count, right? And no more sequence can be formed. Oh, that's smart. Okay, yeah. Otherwise, you just keep. Oh wow. One pass with looping, I suppose. Yep, you have this looping. Yep, because you're just keeping track. You just keep adding this. Nice. Maybe I will try to find another way, but I do have to stop today. All right, I will see you guys tomorrow. Adios.